Bismillah ar-Rahman ar-Rahim. The last part we finished the lecture with the definition of the transpose of a matrix. And we said that to find the transpose of a matrix is just to convert the rows into columns. And we gave two examples about how to find the transpose of a given matrix. This part we are going to speak more about the transpose, and also we are going to give the properties of the transpose of one or two matrices. Have some more examples, and then we are going to state the properties of the transpose. Example. If A or equal to 4, 8 minus 10. B equal to 2, 4, 5. Then find A. Find A transpose A. Product of A transpose A, which is equal to A transpose will be given by 4, 8 minus 10, converted to a row vector, multiplied by A is 4, 8 minus 10. So the first one is 1 by 3. Second one is 3 by 1. So the outcome of this one, since I have 3 and 3, it will be 1 by 1 matrix. It's 1 by 1. Let's try and find this one to see. So the product is equal to first one with the first one, second with the second, third with the third. And we add. We'll have 4 by 4, this is by product of matrices, row by columns, plus 8 by 8, plus minus 10, minus 10, which is equal to 16 plus 64 plus 100. That will be 180. 180. Second one, let's find the A plus B transpose. We said before that to add two matrices, they must have the same size. If they are different in the sizes, then we cannot add them. So let's find A and B transpose. A is given by 4, 8 minus 10, plus B transpose, this will be given there. It is row, vector will be column vector. So the A should be written as column, not row. So given as column vector. Is 4, 8, and minus 10. Plus B, this row, so the transpose will be column. This 2, 4, and 5. And you can see both of them 3 row by 1 column, 3 by 1 column. So they have the same size. We can add them. It will be 4 times 2 is 6, 12, and minus 5, which is 3 by 1. Let's state the properties of the transpose. with that A and B are matrices. B not beta. And K a scalar. Then 1. If we do the transpose 2 times, we'll get the same matrix, A transpose, or the transpose of the A transpose is equal to A. It will go give me back my origin matrix. Number 2, A plus B transpose is equal to A transpose plus B transpose. Number 3, A B transpose equal to B transpose A transpose. Representing the order. The transpose of the multiplication A times B is equal to the product of the transpose of B times transpose of A. Number 4, K multiplied by A transpose equal to K A transpose. For the third one, let's have one example. To verify that A B transpose equal to B transpose A transpose. Let A equal to 3, 4, say 8, 1, and B is equal to 5, 10, minus 2, minus 5. Let's find A, B transpose. It means that we need to find the product first, A times B. A times B is equal to 3, 4, 8, 1. Multiplied by 5, 10, minus 2, minus 5. Row with column. That will give me 3 times 5 is 15, minus 8. Then 3 with 10 is 30, minus 20. Second column, 8 times 5 is 40, minus 2, and 8 times 10 is 80, minus 5, which is equal to 7, 10, 38, and 75. So A, B transpose equal to, now convert the rows into columns, it will be 7, 10, 38, and 75. This is A, B transpose, or the transpose of the multiplication. Let's find second one. I need to find B transpose A transpose. That is equal to B transpose is given by 5, 10, minus 2, minus 5. And A transpose is given by 3, 4, 8, 1. Let's find the product of these two matrices, which is equal to 5 times 3, 15, minus 2 is 4 is minus 8. Second one, 5 times 8 equal to 40 minus 2. Next one, times with 3 is 30 minus 20. 10 times 8 is 80 minus 5, which is equal to 7, 38, 10, and 75. Now, if you compare these together, you see they are equal. So we got that result that A B transpose equal to B transpose A transpose. Now, next point, need to define something called the symmetric and co-symmetric matrices. Matrices. If A equal to A transpose, then A is called symmetric matrix. Matrix. For example, A equal to 4 minus 2 minus 2 and 5. For this one, A transpose equal to 4 minus 2 minus 2, 5. It is equal to A itself. So if the A transpose equal to A, then we say the matrix A is symmetric. And the co-symmetric, if the transpose equal to the negative, it's number 2. A transpose equal to minus A, then A is co-symmetric. For example, A is equal to 0, 1 minus 2, minus 1, 0, and 3, 2, minus 3, and 0. The transpose of this matrix is equal to 0, 1 minus 2, minus 1, 0, and 3, and 2, minus 3, and 0. But this is equal to minus A. If you multiply A by negative, you will get this matrix. So A transpose in this case equal to minus A. If this is satisfied, we call this matrix symmetric. So this matrix is symmetric. Now next one, or next point, that will be upper and lower triangular matrix. Matrices. The matrix A is called upper if all the elements above the main diagonal are non-equal to 0, but the remaining or the element under that one are 0. If we have this form where the main diagonal and all the upper are non-zero, we call it upper triangular. If I have A11 up to A1 and going down up and 1 A, say MN. All of these are non-zero, but the lower of them or the element under the main diagonal are equal to 0, we call it upper triangular. The reverse or the opposite for this one, the lower triangular, 0 everywhere above the main diagonal and non-equal to 0 in the lower or in the, okay, under the main diagonal, we call this is lower triangular matrix. For example, let A equal to 1, 0, 0, 2, 4, 0, minus 1, 1, and 9. This is upper triangular. And B, say it is 1, 2, 7, 0, 4, 1, 0, 0, minus 1. Lower triangular. So this one is upper triangular matrix. This is lower triangular. And we have special matrix, we call it I. That is if all the elements in the main diagonal are equal to 1 and 0 everywhere. For example, 1, 0, 0, 0, 1, 0, 0, 0, 1. We call this is the identity matrix. The identity matrix. And the identity, if you multiply by any matrix, give me the same matrix A. This is special matrix, diagonal matrix, where all the entries on the main diagonal are equal to 1 and 0 everywhere. We call this is a diagonal matrix, and also it is known as the identity matrix. Identity matrix.